So what is the formula to find the sum of n terms of AP? That is Sn is equal to n by 2, 2a plus n minus 1 into d. So the sum of first 5 terms is equal to 1/4 of the next 5 terms. Next 5 terms is A6 to A10, which can be written as S10 minus S5. Finding the common difference in the first term, substituting in the equation 2, we will get the value of m. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our previous session, we have learnt clearly about the sequences and series of arithmetic and geometric progression. And also, we have studied how to write the terms of a sequence whenever the given condition is applied. Now, we will see few problems based on the arithmetic progression and arithmetic series. So, in today's session, we will be taking problems on AP and arithmetic series. Let's see the first question here now. The sum of n terms of two arithmetic progressions are in the ratio 3n plus 8 is to 7n plus 15. Find the ratio of their 12th term. So, we have to find the ratio of their 12th term. So, here sum of two ratios of arithmetic GP are given. So, let me write it as S1 and S2. So, S1 by S2 is given in the form of 3n plus 8 divided by 7n plus 15. Now, for these two terms, the first one maybe differs and common difference may differs. So, n is common here. So, what is the formula to find the sum of n terms of AP? That is Sn is equal to n by 2, 2a plus n minus 1 into d. So, here we can change the variable for a and d. So, I will write this as n by 2, 2a1 plus n minus 1 into d1, and similarly here n by 2, 2a1 plus n minus 1 into d1. This is equal to 3n plus 8 divided by 7n plus 15. So, here I can cancel the term n by 2, n by 2. I am left with here, so it is 2a2 d2. So, 2a1 plus n minus 1 d1, 2a2 plus n minus 1 d2, because we are taking the two different sequences here. Now, we know that any term an can be written as a plus n minus 1 into d. Suppose I need 12th term, then it is a plus 11d. So, they have given that we have to find the ratio of the 12th terms of these two ratios. Now, how I can write the 12th term of the first sequence? I can write this as a1 plus 11 d1. How I can write the ratio of the second one? That is a2 plus 11 d2. So, now I need to calculate the ratio of these two. Now, what I will do here is, I will multiply with 2. So, this equation becomes 2a1 plus 22 d1 divided by 2a2 plus 22 d2. Now, here if this is 22, according to this equation here, if this is n, this is n minus 1. Clearly, this is in the form of 2a1, and if this is n, then this is n minus 1. If this is n minus 1, then this is n. So, let us compare to this now. So, I can write 2a1, n minus 1 into d1 means 22 d1 can be written as 3 into 23 plus 8. Because if this is n minus 1, this must be n. Similarly, here I can write, if this is 2a2, n minus 1 d2. So, n minus 1, if I take it as 22, then it can be written as 7, 23 plus 15. So, now solve this. So, this implies a1 plus 11 d1 divided by a2 plus 11 d2 can be written as, on solving this, we will get the ratio as 7/16. So this is the ratio of the 12th term of the two sequences. Here the conditions are given. We have two arithmetic progression, that is two arithmetic sequences. One is A1 or A2 you can take, whose sum ratio is given. So the sum of n terms of these two progression, for first one I'll take it as S1, for second I'll take it as S2, the ratios are given. So let us use the formula to solve it. We are supposed to calculate the ratio of the 12th term. How the 12th term is written generally? It is written as A12 is equal to A plus 11D using the formula of nth term. So therefore, for the first progression, you can write this as A1 plus 11D1 divided by A2 plus 11D2. Compared to this equation, you have 2A1. So if you want 2A1 here, multiply with 2. So when you multiply with 2, you will get the ratio in this form. Now here they have given n minus 1 d1, then it must be 3 must be multiplied with n. So if n minus 1 you got it as 22, clearly you can say n is equal to 23. So in the place of n, replace 23, solve it, you will get the ratio of the 12th term. So this is how you can find the ratio of the 12th term in this problem. Next problem, the income of a person is rupees 3 lakhs in the first year. He receives increase of rupees 10,000 to his income per year for next 19 years. Find the total amount he received in 20 years. So at the first year, his salary was 3 lakh annual. The next year, 10,000 is added. So it is 3 lakh 10,000. Again, the next year, 10,000 is added. So his salary is 3 lakh 20,000. Similarly, it goes up till 19th year. Now I need to calculate the total amount he received in 20 years. So that is, I need to find out S20, sum of all his salary in 20 years. What is 20? 20 by 2 into 2 into A. A means the first term, that is 3 lakh. Here 0 plus n minus 1, that is 20 minus 1 into D. The common difference each year is 10,000. So using the formula Sn is equal to n by 2, 2 into A plus n minus 1 into D. So solving this we get 10, here it is 6 lakh, and here it is 19 into 10,000. So it is 1 lakh 90,000. So on adding this S20 we get it as, so total we get it as 79 lakhs. So this is his total salary received in 20 years. Next problem, find the sum of odd integers from 1 to 2001. We know the formula that the sum of n terms can be calculated when the first and last term is known. That is, Sn is equal to n by 2 A plus L. So here we have to calculate the sum of odd integers whose first term is 1 and the last term is 2001. So how to calculate now? Sn is equal to n by 2 and A is 1, 2001. What is n now? We need to calculate all the odd numbers from 1 to 2001. So the last term is given now. That is, an is given. So this can be written as Sn is equal to, when you cancel this, this is n by 2 into 2002. So when you cancel, you will get it as 1001 into n. Let me take this as equation 1. Now how to find out n? I can calculate n by knowing the term. I know the last term an is equal to 2001. What is the formula for an? That is a plus n minus 1 into d is equal to 2001. Odd numbers means it is 1, 3, 5, etc. till 2001. So here the first term is 1. Common difference is 2. So let me calculate the first term is 1. n minus 1, common difference to 2001. I'll get here 2n minus 2 is equal to 2000. 2n is equal to 2002. N is equal to 1001. So I got n is equal to 1001. Let me substitute in equation 1. So equation 1 implies Sn is equal to 1001 into 1001. So therefore Sn is equal to 1002001. So this is the total sum of all the odd numbers from the number 1 to 2001. So by knowing the nth term and by using the formula of Sn, when the first and last term is known, we can find the sum of odd integers from 1 to 2001. So next question, find the sum of all natural numbers lying between 100 and 1000 which are multiples of 5. So between 100 and 1000 means after 100, before 1000, we are supposed to find the sequence of multiples of 5. So after 100, you will get 105, 110, 115, etc. And before 1000, you will get 995. So this is the required sequence now. According to it, you have A is equal to 105, common difference is 5, and the nth term is given as 995. I don't know how many numbers are there in total. Let us find out using the nth term. So I have An is equal to 995. So what is the formula for An? A plus n minus 1 into d is equal to 995. A is given, that is 105 plus n minus 1 into 5 is equal to 995. So when you multiply, this is 5n minus 5 is equal to 995 minus 105 becomes 890. Next I have 5n is equal to 895, n is equal to 179. So you have in total 179 numbers from 105 to 995. So now we have total 179 here. So let us find the sum of all these numbers. So we know already the first and last term. We can use the formula n by 2 into a plus l. So therefore Sn is equal to n by 2 into a plus l. So how many total number of terms we have? 179. So 179 divided by 2. A is 105 and the last term is 995. On solving this, the sum of all 179 numbers from 100 to 1000 is 98,450. So this is the value. Next question. In an AP, the first term is 2 and the sum of first 5 terms is 1/4 of the sum of next 5 term. Show that 20th term is 112, minus 112. Let's look at the first term given. A is equal to 2. Sum of first 5 terms, that means S5 is equal to the 1/4 of sum of next 5 terms. Next 5 terms means A6, A7, A8, A9, A10. That I can write this as S10 minus S5. So usually we write this as A1 plus A2 plus A3 plus etc. till A10. This is nothing but S10, sum of 10 numbers. So 5 numbers means A1 to A5. So if you do S10 minus S5, you will get A6, A7, etc. till A10. So this is the logic I have used here. So the sum of first 5 terms is equal to 1/4 of the next 5 terms. Next 5 terms is A6 to A10, which can be written as S10 minus S5. So this can be written as 4S5 is equal to S10 minus S5, or 5S5 is equal to S10. So let us use the formula now. So this is 5 into S5 can be written as 5 by 2 into 2A means 2 into 2 plus 5 minus 1 into D. Next here I have 10 by 2, 2 into 2 plus 10 minus 1 into D. So let's see now, this is 25 divided by 2, 4 plus 4D, 10 by 2, 4 plus 9D. So I can cancel 2 on both sides. It is now 25 into 4, which is 100 plus 100D is equal to 40 plus 90D. Now here I can shift it. 100D minus 90D becomes 10D. Now here I have 40. If I shift 100, it is minus 60. So therefore I will get D is equal to minus 6. Now I need to show that the 20th term is 112. That is minus 112. So that is A20 can be written as A plus N minus 1 into D. So therefore A20, A is given 2 and this is 20 minus 1, D is given minus 6. So A20 is equal to 2 and this is 19 into 6. So which is minus 114. So therefore I got A20 is equal to minus 112. So this is the 20th term. Hence we have proved it. Next question. How many terms of AP minus 6, minus 11 by 2, comma minus 5 are needed to give the sum minus 25? Here they have given A is equal to minus 6 and Sn is given, that is minus 25. We are supposed to calculate N. I even don't know the common difference. Common difference can be calculated as A2 minus A1. So that is minus 11 by 2, minus of minus 6 become plus 6, which is minus 1 by 2. Now let us calculate using the formula. Sn is equal to n by 2 into 2 into A is minus 6 plus n minus 1 into D, that is minus half. Now Sn is given minus 25 is equal to n by 2 minus 12 minus n by 2 plus half. Now cross multiply, this is minus 50 is equal to n into, so this is minus 25 plus n divided by 2. Now cross multiplying, you will get minus 100 is equal to minus 25n plus n square, or you can write it as n square minus 25n plus 100 is equal to 0. So let us solve using the quadratic method. So here you will get it as n square. Since you have minus 25 here, so I can write this as minus 20n minus 5n plus 100 is equal to 0. Take in common factor, we get n minus 20, n minus 5 is equal to 0. So therefore, n is equal to 20 or n is equal to 5. So both are positive here. We have two chances. That is, you may have 20 terms to get the sum as minus 25 or 5 terms to get the sum as minus 25. The next question. If the sum of a certain number of terms of AP is 25, 22, 19, etc. is 116, find the last term. We need to find out the last term. So first, what they have given, Sn is given, that is 116. Next, first term is given, that is 25. Common difference is given, which is 25 minus 3. So difference is minus 3. So we need to find out the last term. First find out the number of terms to find the last term. So now let us calculate it. Sn is equal to n by 2, 2 into 25 plus n minus 1 into D, which is minus 3. So solving this, we have Sn is equal to 116, which is n by 2, which is equal to 50 minus 3n plus 3. Now we have this multiplying, we get this as, so 232, which is equal to, when you multiply this, 50 plus 3 is 53. So you will get it as 53n minus 3n square. Or you get 3n square minus 53n plus 232 is equal to 0. So this is what the equation you get, which is a quadratic equation. So let us use the formula method to find out the value of n. So I can find the value of n is equal to minus b plus or minus b square minus 4ac divided by 2a, that is square root. We take the value of b as 53, c as 232, 3. So which is 53 plus 53 square minus 4 into a is 3, c is 232 within the square root divided by 2a, which is 2 into 3. So on solving this, we get n is equal to, so this when you solve it, so you will get it as 53 plus or minus 5 divided by 6. So you get n is equal to 58 by 6 or n is equal to 48 divided by 6. So n is equal to 29 by 3 or n is equal to 8. So n cannot be fraction because we are counting the number of digits here. So counting is always a natural number. So therefore clearly here n is equal to 8. Now we need to calculate the last term. That is, we have only the 8th term. We have only 8 terms. We are supposed to calculate only the last term. So therefore A8 can be written as A plus 8 minus 1 is 7 into D. So A8 is equal to, what is the first term we have? We have the first term is 25, common difference is minus 3. So it is 25 minus 7 3s are 21, which is equal to 4. So this is the last term of the given sequence. Next question, the ratio of the sum of m and n terms of AP is m square is to n square. Show that the ratios of mth and nth term is 2m minus 1 is to 2n minus 1. This is same as the first one we have did. So they have given the sum of m terms and n terms whose ratio are given in the form of m square into n square. Now I need to find out the ratio of mth and nth term, that is am by an. So first write this. This can be written as m by 2, 2a plus m minus 1 into d. Similarly here n by 2, 2a plus n minus 1 into d. This is equal to m square by n square. We can cancel m, n on both sides and 2 on both sides. Here we are left with 2a plus m minus 1 into d and 2a plus n minus 1 into d, which is equal to m by n. So here it is m minus 1, then this is m. Again, how to write the mth term and nth term? So mth term can be written as a plus m minus 1 into d and nth term can be written as a plus n minus 1 into d. So this is what I have to write it now. So here, comparing these two equations, here I don't need 2. So what I will do, I will divide the equation by 2 throughout. So this becomes a plus m minus 1 divided by 2 into d whole divided by a plus n minus 1 divided by 2 into d. Here it is m by 2 by n by 2, 2 get cancels. So I can write this as m by n only. Now, so let me write m minus 1 by 2 as p minus 1. So let m minus 1 by 2 is equal to p minus 1 and n minus 1 by 2 is equal to q minus 1. So what I will get here, m minus 1 is equal to 2p minus 2 or m is equal to 2p minus 1. Similarly here, n minus 1 is equal to 2q minus 2 or n is equal to 2q minus 1. So therefore, a plus md by a plus nd can be written as a plus 2p minus 1 into d divided by a plus 2q minus 1 into d. So this can be written as, this is equal to 2p minus 1 divided by 2q minus 1 now. So this implies pth term divided by qth term is equal to 2p minus 1 divided by 2q minus 1. Now replacing p by m and q by n, we get mth term divided by nth term, that is equal to 2m minus 1 divided by 2n minus 1. So this is what the required ratio for the mth and nth terms. Next question. If the sum of n terms of an AP is 3n square plus 5n and its mth term is 164, find the value of m. So here sum of n terms is given. Sn is equal to 3n square plus 5n and mth term is given, that is am is equal to 164. What is am? It is a plus m minus 1 into d, which is 164. Now let me take this as equation 1. Let me take this as equation 2. What is S1? S1 is 3 into 1 square plus 5, which is equal to 8. S2 is 3 into 2 square. 2 square is 4. 4 3s are 12 plus 5 2s are 10, which is equal to 22. Now clearly the sum of first term is 8, second term is 22. So S1 is nothing but A, S2 is nothing but A plus D. So we have 2A plus D. According to this, 2A plus D is equal to 22. A is given, which becomes 16 plus D is equal to 22. So therefore we get D is equal to 6. Now we got D is equal to 6, A is equal to 8. Now substituting these values in equation 2. What is equation 2 we have? We have A, that is 8 plus m minus 1 into 6 is equal to 164. So 164 minus 8, that is 6m minus 6, 156. So 6m is equal to 156 plus 6, which becomes 162. So therefore m is equal to 27. So this is the value of m. So using the nth term, we can find the S1 and S2. From S1 and S2, we can find the first and common difference. Finding the common difference in the first term, substituting in the equation 2, we will get the value of m as 27. So we have discussed few problems based on the concept of arithmetic progression as well as the arithmetic series, that is sum of n terms of arithmetic sequence. We'll meet you in the next session with a few more problems. Until then, keep watching, keep learning and keep exploring. Thank you.